Hey everyone, Professor Adjvan here, and in this video I want to talk to you about the limit definition of a derivative, both the concept and where the formula comes from, along with a couple of examples that are very common types of problems that you'll do when you're doing the limit definition of a derivative. Alright, so to start out with the concept, we have a function. Right? We have a line, it's described as f of x. And what we want to find is the slope of a tangent line for any point on this line. So I want to find the slope of this tangent line at this point, right? So to find the slope of a tangent line, we typically need multiple points, right, to find the slope of a line. But we only have one point. Okay, so what we're going to do is we're going to pick another point, any point on the line. Right, so the point that we're looking for the tangent line of we'll call x, and then this other arbitrary point that we pick we can call x plus h. Some textbooks will describe this as x plus delta x, where the h and delta x just represent the distance between the x arbitrary point and the second arbitrary point that we've picked. Alright, both of these points have a height of what could be described as a y, or more accurately an f of x for our red x point, or f of x plus h for this blue x plus h arbitrary point. Alright, so what we have currently is a secant line, right? We have a line that goes through these 2 points. And we can find the slope between these 2 points, right? We can take the difference in their heights, or f of x plus h minus f of x, minus the difference in the x direction, or x plus h minus x, which is just h. Right, so that's going to give it the slope of this tangent line, or the secant line, but we want the slope of the tangent line. So what are we going to do? Well, we want to shrink the distance between these 2 points all the way down to 0. So in shrinking the distance between these 2 points down to 0, we're going to end up with just 1 point. Right? And we have a mathematical way that we can look at that distance between these 2 arbitrary points as it approaches 0, and that's the limit. So we can look at the limit as the distance between these 2 points, which is h, or maybe delta x in whatever textbook you're using, as that approaches 0 of this formula. And then this will give us the slope of the tangent line for whatever point we're looking at. Alright, so this is going to give us an equation that can be used to find the slope of the tangent line of any point on the graph, which is really what the definition of a derivative is. So let's put this formula into action with our first example. Alright, we have the function defined as x squared minus 2. Alright, so we want to put this into the formula of the limit as h approaches 0 of f of x plus h minus f of x all over h. Alright, so we need to really just find this piece, right? This f of x plus h. Alright, so to do that, everywhere we see an x in the problem, we're going to replace it with this x plus h. So I need to do x plus h squared, and that means that we have to FOIL this out. Okay, a very common mistake I'll see is just distributing the squared and saying x squared plus h squared. No, this is a binomial squared, so we have to FOIL it. Right, and in foiling it, we should get x squared plus 2xh plus h squared, and then we still have this minus 2. Alright, so this can go into the formula for f of x plus h. Right, we can have x squared plus 2xh plus h squared minus 2. And then we have minus f of x, right, which is given to us in the problem, minus x squared minus 2. And notice how I've put everything in parentheses. And then we still have this divided by h, and we're still doing the limit as h approaches 0. Alright, now if we plugged in 0 for h at this point, and really at the previous point, we would end up with 0 over 0, which we know is an indeterminate form and tells us that we can do something more to the problem. Alright, so let's simplify this down a little bit. Let's clean it up and see what happens. The first thing I want to recognize is that we have this minus x squared, and we also have a positive x squared in the very beginning. Those are going to cancel out. We have a negative 2 here, and I have minus a negative 2, so those are going to cancel out as well. So notice how everything that we have left in the top, each term, has an h in it. If not every term with an h is canceling out, then you've done something incorrectly. Maybe you flipped a sign, or you forgot to distribute something or multiply something out correctly. Everything without an h in the numerator should cancel. And this is because when we get to this point, we want to factor an h out of the top so that we can cancel it with the h in the numerator, or in the denominator. And once we've canceled with this h in the denominator, that's when we actually want to go ahead and evaluate the limit. Right, so I want to evaluate the limit of 2x plus h as h approaches 0, which is just going to cancel out the h term, leaving us with 2x. So this 2x is a formula that I can use to find the slope of the tangent line at any point along the function x squared minus 2. Right? And then I can use that slope and the point, whatever point I'm looking at, to find the equation of the tangent line at that point. All right, we have another example, but this time with a square root. All right, so same thing. I want to use the formula, the limit as h approaches 0 of f of x plus h minus f of x all over h. And again, we need to figure out this part, the f of x plus h. Right, so everywhere in my function where there is an x, I want to put x plus h. All right, so I'm going to replace this f of x plus h in the formula with the square root of x plus h plus 3. Right, I have the square root of x plus h plus 3 minus f of x, and we know f of x is the square root of x plus 3, all over h. Now, because these are not the same things within the radicals, we can't combine them. All right, so there is something we can do, because if we were to actually do the limit right now, we would see that this is in an indeterminate form. And the square roots are a hint for what we should do. What we should do is multiply by the conjugate of these roots. Right, so instead of doing minus, we're going to do plus. Right, so I'm going to multiply both the top and the bottom by the square root of x plus h plus 3 plus the square root of x plus h. All right, so let's do that. Well, when we multiply conjugates, we only need to square the first term. So we're going to square this, canceling the square root, giving us x plus h plus 3 minus the second term squared, which will cancel the square root, giving us x plus 3. And in the denominator, the pieces that aren't conjugates, we're never going to multiply them because that's just going to be extra work that we don't need to do. All right, so we're here at this point. Now, before we plug in this 0 for h, let's go ahead and simplify the numerator. All right, we have an x and we have a minus x. Those can cancel. We have a 3 and a minus 3. Those can cancel. And now we're left with just an h on top, and then h times our conjugate piece, the x plus h plus 3, plus the square root of x plus 3. Now, because I have an h on top and I have an h on bottom that's being multiplied by another binomial, we can cancel those h's, leaving us with the limit as h approaches 0 of 1 over our conjugate piece. And just like in the last problem, as soon as we cancel out the h in the bottom and top, we can go ahead and actually evaluate the limit. We can actually plug in the 0 for h. So I can have 1 over, if I plug in 0 here, I'm going to have the square root of x plus 0 plus 3 plus x plus 3, root x plus 3. Right, so this is going to be the square root of x plus 3 plus the square root of x plus 3, or 2 square root of x plus 3. And this will be the function that we will use to find the slope of the tangent line of any point that we want for the function, the square root of x plus 3, and then we can use that point and that slope that we found to find the actual equation of the tangent line. All right, so this hopefully clears up and explains a little bit better how to use the limit definition to find a derivative. If you found this video helpful, consider giving it a like and consider subscribing to the channel for more math content like this. Thanks for watching, good luck, and we'll see you in the next one.